Welcome to Foundational Patterns. In this lesson, we are discussing the calculation of volume and surface area in 3D objects. This is a topic found in shape, space, and measurement in mathematical literacy, IET level 4. Now, first we want to define some few terms. One is to define volume. So we say volume is basically going to be the amount of space that an object occupies. So an object occupies space and it takes up space, so that is what volume is. Another alteration to this will be when we talk about capacity. So capacity is not volume, but the calculation basically is the same. So capacity is the amount of space inside a 3D container. Right. Now, at this point, I just want to make a very crucial comment and say that volume will be equals to the area of a base multiplied by height. So this is very important because every time we calculate for volume, we will see that there is some bits of the formula of area of a base in the calculation of the volume. All right. Then next, we want to talk about surface area and say surface area is actually the sum, or when you add of the areas of all the faces of a 3D solid. Okay, so that is what surface area is. So surface area and volume are what we use to calculate in the 3D shapes. Whereas in the 2D shapes, you'll remember that we calculated for perimeter and area, and we can check out the previous video for that. Now, we do not calculate volume and surface area for all the 3D objects or 3D solids. There are selected few. So in mathematical literacy, level 4, which we call MLMS4. This is the code for it. We do not calculate anything that has to do with the pyramids. So in terms of the pyramids, we don't do that. We can calculate the triangular prism. We can calculate a square-based prism or a rectangular prism of some sort and a normal rectangular prism. We do not calculate anything that has to do from pentagonal prism, hexagonal, octagonal, nonagonal, decagonal. So we don't calculate these ones here. But in addition to a triangular prism, a rectangular prism, we do, of course, calculate for a cylinder. So we do calculate the volume and surface area of a cylinder. All right. So please remember that. Now we just want to start here and introduce what we are dealing with today in this case. So for instance, we call a shape like this 3D because it has a length, a breadth, and a height. Okay. So volume also has to do with the space that is covered from the length and the breadth and the height. So in this case, we'll have 1 centimeter by 1 centimeter by 1 centimeter. So basically we'll have 1 cubic centimeters or 1 centimeters cubed. So this block here or what we can call a cube, occupies 1 cubic centimeter. Now, if we can say that, it means then we can also look into this bigger one and say, right, if one block occupies 1 cubic centimeters of space, then how many does 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks cover? So there's 10 of these cubes, right? So it means they will be covered by 10 cubic centimeters, or centimeters cubed, all right? So there is 10 of them. And of course, in the next one, because it is the same layer as the top one, it will be 10 centimeters cubed as well, all right? And the next one will be 10 centimeters cubed. So essentially we are saying this shape, all of it, covers 30 blocks, or is covering a space of 30 blocks, or 30 centimeters cubed. All right. So that is what we call, when we are counting the blocks. Now, in terms of surface area, I want to talk slightly and say, if we take this block here, all right, and we open it into its net. Remember, we spoke about the net in the previous video, so you can check it out. We can break it into its net, so we'll have this part here will be this one, all right? And then this one will be this square here. And then this square will be here, all right? And notice something. If we can have a square on the right, we can also have a square on the left to complete our cube, all right? And then the bottom one, we put it here, and then the back one, we can also put it there. So you will notice that a cube actually has 6 faces, or 6 sides, all right? So these ones are faces. Now, what do we do when we calculate surface area? One, we can say for surface area, we know we have how many blocks? We have 6. This block has 6 faces, so we can simply say one face. What is the area of one face? The area of one face. So the area will be 1 centimeter by 1 centimeter. So we can simply say it's length times breadth. So obviously it will give us 1 centimeters squared, all right? So which means if we look at it, this one here is 1 centimeter squared, 1 centimeter squared, 1 centimeter squared, 1 centimeter squared. So essentially we'll have 6 times 1 centimeters squared, all right? Now, so that will be what surface area is covering this block here. What about the big one here? Now, if we look at the top we have 1 centimeter squared, 1 centimeter squared, 1, 2. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it means we'll have 10 times 1 centimeters squared, because each one of them is 1 centimeter squared. So this is for the top, all right? And what about the bottom? Obviously, we cannot see the bottom, but we assume that the bottom is the same. So it will be 6, it will be 10 blocks, which are covered by 1 centimeters squared, okay? So that's what basically happens here at the top, and the bottom will be the same, all right? And then we can also look at the front. So for the front, it is covered by 1, 2, 3, 4, 5, 6. So it will be 6 times 1 centimeters squared, all right? And this one here, the back, which we cannot see, but the back is the same as the front. So it will be 6 centimeters, 6 times 1 centimeter squared, all right? And I said it is the front. It's actually going to be, this one here is incorrect. I was speaking about the front, so the front, okay, bear with me. The front will have how many blocks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it will be 15 times 1 centimeters, and the back will be the same, which is 15 times 1 centimeters squared, all right? So, and the right-hand side, which we can see, it has 1, 2, 3, 4, 5, 6 blocks, so it will be 6 times 1 centimeter, and as well as the left-hand side, this one here, will have 6 times 1 centimeters squared. All right, so basically that's what we will have here. Now, in terms of the surface area, it means we'll have this one here is 10 times 1 centimeter, which is 10 centimeters squared, and the front will have 15 times 1, which is 15 centimeters squared, and the right will have 6 centimeters squared, and it's the same for this one here, 6 centimeters squared, 15 centimeters squared, and we'll have 10 centimeters squared. So you'll notice that if you add 10 centimeters and 15 centimeters and 6 centimeters, you will end up with 31 centimeters. And for the same, on the other sides, the bottom, the back, and the left, it has the same. So it will be 31 centimeters squared as well. Or you could have said it is 2 times 31 centimeters squared. So essentially, this will give you 62 centimeters squared. Pardon, I don't have enough space there. All right, so basically, this shape here has been covered by 62 centimeters squared of material. All right, so that's basically how we can use counting of blocks in order to understand volume and surface area. Next, I want us to look into the formulas, all right, for different objects that we're dealing with. So in this case, we have this one here, it's a rectangular prism. Rectangular prism. So it has the formula for volume is equals to length times breadth times height. So which means it is the length times breadth times the height, okay? But now, I want us to look into the surface area, which I have abbreviated it to SA. The surface area will be the length of the top times the breadth, all right? So it's the length times the breadth. It's a rectangle, as you can see. So it will be this one here. But because we have the top and the bottom being the same, so that's why we have these two here, all right? And the same, we have the length and the height. So the length and the height talks about this rectangle here, okay? So it is the rectangle of the front and the back is the same. So we are saying it's 2 times the length and the breadth because the front and the back are the same. And you notice that there is the breadth and the height. So the breadth and the height is this rectangle here, all right? We have the breadth and the height for it. So in that case, we say we must multiply by 2 as well because the right-hand side is the same as the left-hand side, this side here that we cannot actually see. Okay, so that's why we have the surface area as 2 times the length plus the 2 times the length times breadth plus length times height plus breadth times height. So that is the formula that we have there. And then the volume. In terms of the volume, we say the volume of the cube. So this is the cube. So the volume of the cube is given by side cubed, all right? We say this is the side. So this side is equals to this side here because it's a cube, and it's also equals to this side here. So basically all the sides of the cube are equal, all right? So we simply say it is side cubed. So that is where, if we are going to refer it back to the rectangular prism, we would say this is the length, and this is the breadth, and this is the height. So, but because they are all the same, we'll have the length times the breadth times the height. So which simply say side, side, side. Side times side times side, which is side cubed. And again, if we look at this face here for surface area, we say the area of this face here, it will be side times side. So, pardon me, I'm just going to change this formula slightly. It's still correct, but I just want to change it slightly and write it as SA, or surface area, is equals to 6 times side squared. Because when we get the area of this face here, it will be side times side, so it is side squared. So because this face is equals to this one, is equals to this one here, is equals to this one, and it's equals to that one, it's equals to this one at the back. So we simply say there's 6 of them, and we don't need to calculate each one of them. As long as they are all equal, we can take one of them and multiply by 6. Okay. The next one is called the triangular prism. Now, with the triangular prism, obviously we have dealt with the calculation of area of a triangle. So the triangular prism, we will want it to have a perpendicular height here. If it is not a right angle triangle that already has a height, so then if we have a height there, and then so this side here will be the base. Okay. Now, for volume, we can say the volume of the triangle will be half base. The area will be base times height, whilst the volume will be half base times height times this height here, which will give it a capital letter height. Okay, I missed it there. So we will have this height here. So we have the height of the base, which is a small letter height, and the height of the entire object, which will be given as a capital letter height. For surface area, we will say we have A, B this side, all right? This side here will be B, and then this side will be C. So we have basically a triangle like this, which will have A, B, and C. And then this height here is capital letter H, and this one here is still capital letter H. So for surface area, we'll say the height of the object is equals to the perimeter of the base, which is A, B plus C, plus B times H. Okay. Now, B times H comes from the fact that there are 2 triangles, this front one here that we can see, and the back one. So it will be half times, it will be 2 of these triangles, okay? 2 of these triangles, and they have half times base times height. Let me write it in short. Half base times height. So the half will cancel the 2. So that's why we have BH for this one here. Okay. Next, we are looking at the cylinder. Now, a cylinder will have a radius, okay, which will be the distance from the center of the circle to the circumference, so we call that the radius. Now, when we look at the previous one where we had a circle, and the area of a circle, we said it's pi r squared. In this case, it's pi r squared h. Remember, we said that the volume is actually the area of the base times the height. Okay, so that's where it comes from. And then the surface area, we have 2 pi r squared because this base here and the base at the bottom, so there's 2 of them. So these are circles. And then 2 pi r squared h is this section here, which is a rectangular part when we open this cylinder. All right, I hope that introduces our formulas nicely. Now, without going into too much detail, we said the formula for the volume will be equals to length times breadth times height. So this is for the rectangular prism, right? So it's the length times the breadth times the height. But then the surface area we said it is 2 times length times breadth, this one here. Or we can simply say it is this one here, which will be length times breadth. So it's this one. But because there's 2 of them, it will be this one equals to this one. So it will be length times breadth as well, all right? Plus, then the front, this one here is the front, it will have the length and the height. But because this one is equals to this one, so we have the length and the height, and there's the 2 there that multiplies them, all right? And then we have what? We have the right-hand side, which will have the breadth, and it also has the height. This one times that, all right? It will be the breadth times the height. But because the right-hand side is equals to the left-hand side, so that's why we also have the 2 there, all right? So that is basically what happens with the rectangular prism. Now, let's look at the cube. The cube, obviously, for the volume, we remember in the rectangular prism, we would say the length times the breadth times the height. In this case, we have side times side times side, okay? Or we can simply say it is side cubed, so we don't need to go into that. So this becomes our formula. But now, what about the surface area? The surface area of a cube is some kind special, because if you look at the bottom square here, so it will have a side times a side, all right? So the area of this one here will be, side times side, so this will be side squared. But this one here, this one is equals to this one, 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 is equals to this one. So we simply say it is 6 times side squared, okay? 6 times side squared, because there's 1, 2, 3, 4, 5, 6 of them, okay? So the net actually helps us to understand how we get the surface area. With this one here, we have a triangle, which is the base of the triangular prism. So this triangle here, the area of the triangle, we say it is area will be half times base times height, okay? But if we are looking for volume, we say volume is equals to the area of the base, so it is going to be half times base times height. Now we include the height of the prism, which is a capital letter H. So that is how we find the volume. Now for surface area, which I just say is SA, for surface area, we look into all the areas. So we have 2 triangles. Before maybe I get into the triangle, so we will say this side here, it's A, this one is B, and this one is C, all right? So we will say the perimeter, which is A plus B plus C of the base, we multiply it by the height. So then it will give us the area of this one, the area of this one, and the area of this side there, okay? It will give us the area of those sides. Plus, now we have the rectangles here. We have the triangle, not the rectangle, the triangle at the front and the triangle at the back. So the triangle at the front has the area, which is half base times height. This one here has the area half base times height, okay? So there's 2 of them. So if there's 2 of them, we simply say 2 times half times base times height. So this half will cancel that, so we are left with base times height. So that's why we'll have base times height. So we have now covered this section here, covers this one, and this one, all right? And then this one covers the 2 triangles. So that's how we get the formula for surface area of a triangular prism. All right. Then the next one, we have the cylinder. Now with a cylinder, we say the volume of a cylinder is given by pi r squared h. Now remember the area of a circle, okay? The area of a circle, we said it is pi r squared. So which means This circle is a base to the cylinder. So the circle, the cylinder has two bases, one at the top and one at the bottom. So the area of the base times the height gives us the volume. What about the surface area? Now I'm going to use the net for this one as well to understand the surface area. Now the area of the circle is pi r squared, but there are two circles, one at the top and one at the bottom. All right, so this one and this one here. So we simply say is 2, because there's two circles, pi r squared, plus then this one here. So this one is a rectangle, but when you close it, it becomes more like a pipe. So this length here is actually going to be the circumference. All right, so the formula for the circumference is, let me write it in full. Circumference is equals to 2 pi r. All right, so the length is actually going to be equals to 2 pi r. And what about the breadth? So this breadth here is actually the height. So this is the height. So I'm just going to write it as h. H is equals to the breadth. All right. So now when we look at the area here, instead of saying its length times breadth, we'll say area is equals to 2 pi r h. Okay. 2 pi r h. So we put 2 pi r h here. So this becomes the formula for the cylinder. All right, I hope it makes sense. Okay, so that's basically it in terms of understanding the formulas. All right, so in the next lesson we'll deal with calculating the volume and surface area of the object. So we'll deal with some few examples. All right, thank you for watching. See you in the next video.